All right, so in this lesson, we're going to be applying what we learned about sine, cosine, and tangent, and applying it to find side lengths. So the directions tell us to find the value of x and to round to the nearest tenth. Right, so if it helps you, go ahead and write, somewhere write SOHCAHTOA. This will help you remember. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So remember, now this is where we're going to learn which trig ratio to use with the information that we're given. So let's look at, and before we start, I want you guys to, because you're going to need a graphing calculator for this. And what I want you all to do first is, so go to your home screen, just turn on your graphing calculator and click the mode button, which is to the right of the blue second button, right? So click mode, and you're going to be brought up to this menu with a bunch of words, right? The important one is to go to where you see where it says, right now it's highlighted in pink, where it says radian and degrees. So I want you all to make sure that you hover over degree and click enter, so that when you scroll away from it, the degree is the highlighted word. And the reason that we want this to be set is we're going to be working with degrees, just like in our worksheet, the angles that we're given is in degrees, right? So we're not going to be working with radians in Algebra 2, so just make sure that it is set to degrees. Because if you don't have it set to degrees, you're going to get the wrong answer. Okay, so back to number one. So for number one, we're given this angle right here, right? And we're looking for what this side length is. And the other information that we're given is the length of the hypotenuse, right? All right, so we're given this angle right here. And this side compared to the angle is opposite, right? This is the opposite side. And we also have the hypotenuse. So we have opposite and hypotenuse. The trig ratio that has that is sine, opposite over hypotenuse. So we're going to use the sine function. So I'm going to write sine of theta, and remember theta represents the angle, so I'm going to replace theta with 64 degrees, is equal to, and it's going to be the trig ratio, opposite over hypotenuse. So opposite is x, and hypotenuse is 25. So sine of 64 degrees is equal to x over 25. So now we need to solve what x is. So the first thing that we're going to do is we're going to go to our graphing calculator and figure out what sine of 64 degrees is. So you're going to go to your calculator. So go back to the normal menu. And when you're here, look at the 7 button, and 2 buttons above that is sine, to the right of that is cosine, and to the right of that is tangent. So we're going to use sine, right, and sine of 64 degrees. And when you click enter, so sine of 64 degrees, you should get 0.8987. So if you did not get that value, it is because you have it set to radians. So make sure that you have your settings set to degrees. So 0.8987. So 0.8987 is equal to x over 25. All right, so now we want to solve for x. So we want to get x by itself. To get rid of it, when you have a fraction, to get rid of the denominator, you're going to multiply the fraction by the denominator. So if I multiply both sides by 25, I'm going to get rid of this 25 over here, and I'm going to go back to my graphing calculator. So I'm going to start typing again. As soon as you start typing again, it's going to bring the answer that you just got back down. So our answer times 25 is 22.469. We're going to round to 22.5 because that's what the instructions tell us. So x is equal to 22.5. All right, so hope that made sense. So now let's go over to number 2. So for number 2, we're given this angle, we're given this side right here, and we're given this side right here. So this is the hypotenuse, right? We're not given the hypotenuse. We don't want to find out what the hypotenuse is. So we're dealing with the opposite angle, which is x, and the adjacent angle, which is 12, right? So this is the adjacent angle, and this is the opposite angle. So if we go back to SOHCAHTOA, tangent is opposite over adjacent. That's the one that uses both of the lengths that we have, that we're given and that we're looking for. So we're going to use tangent here. So tangent of 47 degrees is equal to opposite over adjacent. So x is the opposite, and at 12 is the adjacent, so x over 12. So we're going to do the same thing that we did for the sine, right? I'm not going to write out all the steps because you guys should see it now. So what we did over here is we found out what sine of 64 degrees is, and then we multiplied it by 25, right? So I'm going to find out what this value is, and then I'm going to multiply both sides by 12, right? Here, let me move it a little bit. So I'm going to multiply both sides by 12 because it's going to get rid of this. So then on my calculator, I need to do 12 times tangent of 47 degrees. So you can write it all out like this. So 12 times tangent of 47 degrees. And you get 12.86, which will round up to 12.9. It would have been the same thing if you done tangent of 47 and then multiplied that value by 12. Right, same thing, just making it less steps. So 12.9 is x here. So x is equal to 12.9. So this side is 12.9. Over here, this side is 22.5. All right, so let's look at number 3 now. So for number 3, excuse me. So for number 3, we're given this angle right here. And so we're given the hypotenuse, and we're given the adjacent side. So cosine is the one that deals with adjacent and hypotenuse. So we're going to use cosine. So we're going to write it cosine of 18 degrees is equal to, so cosine is adjacent over hypotenuse. So the adjacent side is x, and the hypotenuse is 34. So same thing like the previous two. I'm going to multiply both sides by 34. Gets rid of this right here. So on my calculator, I need to do 34 times cosine of 18 degrees. So clear everything out. Cosine of 34 times cosine of 18 degrees. Click enter, and you should get 32.3. So for number 3, x is equal to 32.3. All right. Number 4, let's look at that one. So we're given this angle right here. We're given the opposite side, and we're looking for the adjacent side. So opposite and adjacent, that's tangent, right? Opposite over adjacent. So we're going to use tangent here. So tangent of 35 degrees is equal to, and so remember, this is opposite over adjacent. The opposite side is 9, and the adjacent side is x, so 9 over x. So this one is a little different, right? Because x is in the denominator now, right? So I'm going to work out the all before I find any values. I'm just going to show you guys like the algebra behind this so that you guys know what to type into your calculator, right? So first we want to get rid of this denominator, right? So I'm going to multiply both sides by x. Get rid of the denominator here. So now I have x times tangent of 35 degrees is equal to 9. Or not 0, to 9. Well, I want to get x by itself, so I want to get rid of this tangent right here. So I'm going to divide both sides by tangent of 35 degrees. Tangent of 35 degrees. So on this side, it gets rid of it. And then I have x is equal to 9 over tangent of 35 degrees. All right, so that's what you're going to type into your calculator now. And I showed you guys all the math on how to do this, but what you could have done from the beginning when you have tangent, when you had tangent of 35 degrees is equal to 9 over x, you're just going to switch x and tangent, right? So when you do that, you're going to switch x and tangent, so x goes over here, and tangent goes down here, which is x is equal to 9 over tangent of 35 degrees, which is what we have over here anyway, right? That's just I'm just showing you that because that's going to be a shortcut for other examples that we're going to do so that we don't have to do all this math right here, so we can get our answer as quickly as possible. So I'm going to go back to my graphing calculator, and I'm going to type in 9 divided by tangent of 35 degrees. So 9 divided by tangent of 35 degrees, and we get 12.85, which will round to 12.9. So here, x is equal to 12.9. All right, let's look at number 5 now. So number 5, we are given this angle right here. We're given the hypotenuse, and we're given the opposite side. So the trig ratio that deals with opposite and hypotenuse is sine. So sine theta, or sine of 63 degrees, is equal to opposite over hypotenuse. So 27 over x. So we have 27 over x. So x is in the denominator, similar to number 4. So you can do all this math if you want to, or you could just switch x and sine because you're going to end up with that anyway when you do all the math. So just a quick shortcut. So I'm going to rewrite this as x is equal to, right, because x goes into the sine position, 27 stays in the same spot, and then sine goes into the x position, right? So sine of 63 degrees. So you can go through all that math if you want to confirm that we're doing it correctly, but you're going to end up with this anyway, so I suggest to take the shortcut. So you're going to go to your calculator, and you're going to type in 27 divided by sine of 63 degrees. So 27 divided by sine of 63 degrees. Click enter, and we get 30.3. So for number 5, x is equal to 30.3. So this side right here is 30.3. And now you could find these, in all these examples, you could find the other missing side if you wanted to, using the Pythagorean theorem, right? All right, so let's go to number 6. So for number 6, we have 30 degrees. We're given this 30-degree angle, and we're given this side, which is the adjacent side, and we're looking for the hypotenuse. So this is adjacent, and hypotenuse is cosine, right? So we're going to do cosine of 30 degrees is equal to adjacent over hypotenuse. Adjacent is 18. So 18 over hypotenuse, which is x. And just like numbers 4 and 5, since we have x in the denominator position, what we're going to do is we're going to switch these two. Right? So I'm going to rewrite this. So x is equal to 18 over cosine of 30 degrees. So you're going to go to your graphing calculator. You're going to type in 18 divided by cosine of 30 degrees. Oh, whoops, not 3. Whoops. Cosine of 30 degrees. And you get 20.78, which we'll round to 20.8. So x is equal to 20.8, which is this side right here. All right, so this is pretty simple. Once you get the math part down, you let your graphing calculator do all the work. And just make sure that you have it set to degrees and not radians. All right, so now for this next part, we're going to be finding angle measures. And so this says if you know the sine, cosine, or tangent ratio of an angle, you can use the inverse of the ratio, which is denoted in this manner. So sine with the exponent -1 is the inverse of sine. Cosine with exponent of -1 is the inverse of cosine. And tangent with an exponent of -1 is the inverse of tangent. So we're going to use the inverses of our trig ratios to help us find the measure of an angle. So this says that if sine theta is equal to x, then theta is equal to sine, or sorry, the inverse of sine of x. So basically what we're doing is, so remember, x is opposite over hypotenuse. And so we're going to be putting opposite over we're going to use the inverse sine function in our graphing calculator. And we're going to put the two angles, or sorry, the two side lengths that correspond. And we're going to then use that function to help us find the measure of the angle. All right, so then if cosine theta is equal to x, then that means that theta is equal to the inverse of cosine of x. All right, so we're going to use, so if we're looking for a length, or sorry, an angle, and we're given the adjacent and the hypotenuse side, we're going to be using this function right here. All right, and then if tangent theta is equal to x, then that means that theta is equal to the inverse of tangent of x. All right, so let's look at some examples now. So this tells us to find the missing angle. All right, so here for number 7, we're given, so we're looking at this angle right here. We're given the opposite and the adjacent side, right? So if you look back over here, opposite and adjacent is tangent. So it's, and remember, tangent is opposite over hypotenuse. So this is, so tangent theta is equal to 8 over 14, right? This you can think of as x over here, right? So that means that when we're going to use the inverse function to find the value for theta, so theta is going to be equal to the inverse of tangent of x, which is 8 over 14. So we're going to type this into our calculator to give us the measure of the angle. All right, and we're going to round to the nearest tenth, so we're going to go back to our calculator. All right, so look again at the tangent, the sine, cosine, and tangent buttons. If you look right above it, like to the left, it says sine inverse, so sine to the -1 exponent, cosine to the -1 exponent, tangent to the -1 exponent. So those are the those are going to be the functions that we use. So remember we had theta is equal to tangent, or sorry, theta is equal to the inverse of tangent of 8 over 14. So you're going to activate that function, since it's in blue, you're going to click the blue second button, and then you're going to click the tangent button. So second and tangent brings up the inverse of tangent. And we had, so we said we were going to type in the inverse of tangent of 8 over 14. Right? And that gives us our measure of the angle, 29.74. So we'll just round to 29.7. So in number 7, theta is equal to 29.4 degrees. That is the measure of this angle. All right, so let's go to number 8. So we're looking for this angle right here. And we're given the adjacent side and the hypotenuse. So that's cosine, right? So cosine theta is equal to adjacent over hypotenuse, so that's 38 over 40. And if you look right here, so if cosine theta is equal to x, so cosine theta is equal to x, then theta is equal to the inverse of cosine of x, which is 38 over 40. So this is what you're going to type into your graphing calculator. So you're going to go back. Oops, wrong one. So we're going to type in the inverse of cosine, so second and the cosine button. And so the inverse of cosine of 38 divided by 40. And you get 18.19, or we can round up to 18.2. So here, theta is equal to 18.2. So this angle has a measure of 18.2 degrees. All right, if we look at the back side, now we're at number 9. So number 9, we're given theta, and we're given the hypotenuse and the opposite side. So that's sine, right? Sine is opposite over hypotenuse. So sine theta is equal to opposite, which is 17, over hypotenuse, which is 22. And theta is going to be the inverse of sine of 17 over 22. So this is what you're going to type into your calculator. So you're going to type second and sine. So the inverse of sine of 17 divided by 22. Click enter, and you get 50.59. So we'll round up to 50.6. So theta is equal to 50.6. So that is the measure of this angle right here. All right, number 10. So for number 10, we have theta right here. And this is the adjacent side, and this is the hypotenuse, right? So adjacent over hypotenuse, that's cosine. So we get cosine theta is equal to adjacent, which is 11, over hypotenuse, which is 48. And then theta is equal to the inverse of cosine of 11 over 48. So this is what we type into our calculator. So click clear everything out, click second and cosine, and you get the inverse of cosine of 11 divided by 48. Click enter, and you get 76.75, or 76.8. So theta is equal to 76.8 degrees. All right, so now we're going to go over angle of elevation and angle of depression. So here we're given a diagram. So for number 11, it says the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? Okay, so what we're going to do first, let's draw a triangle. Let me draw a better triangle. Okay, so let's say that the boat is right here. That's good enough. And so this says that the angle of elevation from a fishing boat to the top of the lighthouse is 5 degrees. So let's say that this is the lighthouse right here. I don't know how to draw a lighthouse. So this is the top of the lighthouse right here. So this angle of elevation right here is 5 degrees, right? And so we know that, so it says the top of the lighthouse is 161 feet from sea level. So the boat is at sea level. So that means that this side is 161 feet. And we want to know how far the boat is from the lighthouse. So we want to find this length right here. Okay. So we're given this angle, and we're given the opposite we're given the opposite side, and we're looking for the adjacent side. So that's we're given opposite and adjacent. So we're going to use tangent. So tangent of, so tangent theta, and we know that theta is 5 degrees. So tangent of 5 degrees is equal to opposite over adjacent. So 161 over x. Right, so 161 over x. And if you remember from the previous examples, when we have a situation like this, we're going to switch tangent and x, right? So I'm going to rewrite this in terms of x. So x is equal to tangent, or sorry, not tangent. X is equal to 161 divided by tangent of 5 degrees. So this is what I'm going to type into my calculator, and I'm going to find the boat length. So x is equal to, we're going to go to our calculator. We're going to type in 161 divided by tangent of 5 degrees. And we get 1,840.23. So we'll just round up to 0.2. So 1840.2. So the boat is 1,840.2 feet from the lighthouse. All right, next. The angle of elevation from the bottom of a slide to the top of the slide is 44 degrees. If the top of the slide sits 16 degrees above the ground, find the length of the slide. Assume it's a straight line. All right, so we're going to assume it's a straight line, so it is a triangle, right? So we're going to start off by drawing our triangle. And here, let me draw a better one. More realistic for 44 degrees. Okay. So this is a 44 degree angle right here. And so it was, we were told that the top of the slide is 16 feet above the ground. So that means that this length is 16 feet, right? And it tells us to find the length of the slide. So this is the slide right here. So we're looking for the hypotenuse, right? So we have 44 degrees, and we're given the opposite side, and we're looking for hypotenuse. So we're going to be using sine. So sine of 44 degrees is equal to opposite over hypotenuse, so 16 over x. So again, just like the previous example, we're going to switch these two when we write it in terms of x. So writing it in terms of x, I get x is equal to 16 over sine of 44 degrees. So this is what I'm going to type into my calculator. So 16 divided by sine of 44 degrees. And we get 23.03, which is round to 23 feet. So x is equal to 23 feet. All right, let's go to number 13. Number 13 says a 10-foot ramp is used to unload furniture from a truck. If the back of the truck sits 3 feet above the ground, find the measure of the angle that the ramp makes with the ground. All right. So same thing, we're going to draw our triangle. And so the 10-foot ramp, so it's a 10-foot ramp, right? So this part is the ramp. So this is 10 feet. And it says that the back of the truck sits 3 feet above the ground. So this part is 3 feet. Right? And now we're looking for, it says find the measure of the angle that the ramp makes with the ground. So this is the ramp, this is the ground. So this is the angle that we're looking for. So we're looking for theta. All right. So in reference to this angle, we're given the opposite and the hypotenuse. So we're going to be using sine, right? So sine theta, sine theta is equal to opposite over hypotenuse. Opposite is 3, and hypotenuse is 10. So now, to find the angle, remember we're going to use the inverse of sine. So we're going to rewrite this in terms of theta. So theta is equal to the inverse of sine of 3 over 10. All right, so this is what we're going to type into our graphing calculator. So we're going to go to graphing calculator. Second and sine gives us the inverse of sine of 3 divided by 10. You click enter, and you get the angle is 17.45, so we'll round out to 17.5. So theta is equal to 17.5 degrees. This angle right here is 17.5 degrees. All right. So that is angle of elevation. You're going to be given some word problems like this, so make sure that you understand how to draw this out. All right, now we're going to look at angle of depression. So we're given a diagram, so our triangles are going to look like this. All right, so for number 14, it says, excuse me, it says a fire is spotted from the top of a 120-foot tall fire tower. The angle of depression to the fire is 19 degrees. How far is the fire from the base of the tower? All right, so let's say that this is the fire tower right here, right? Just so you guys know what I'm doing. So let's say this is the fire tower. So from the top, which is right here, there is the angle of depression is 19 degrees, right? So our triangle is going to look like this. All right, let me erase the tower. Now that you guys know what this would look like. Okay. So this is the top of the tower, right? So from the top of the tower, so fire spotted from the top of a 120-foot tall fire tower. So this is 125 feet right here, right? Because this is this right here is the same as the top of the tower. And so the angle of depression of the fire is 19 degrees. So this is the angle of depression, 19 degrees. How far is the fire from the base of the tower? So we're looking for this length right here, because this would be the same as like down here, right? So from the base of the tower would be right like that. But it's the same as this length right here. So I'm going to be looking for this length. So we're given this angle, and in reference to this angle, this is the opposite side, and this is the adjacent side. So we're going to be doing tangent. So tangent of 19 degrees is equal to, and tangent is opposite over adjacent, so 125 is opposite, and adjacent is x. So we're going to switch these two to write it in terms of x. So x is equal to 125 over tangent of 19 degrees. And we're going to type this into our calculator, and we get x is equal to, so 125 divided by tangent of 19 degrees. And when we click enter, we get 363.02. So we'll just round down to 363 feet. So x is equal to 363 feet. All right, so this length, which is the same as this length, is 363 feet. All right, so for number 15, it says an airplane is flying at an altitude of 8,900 feet over the water. The pilot spots a raft floating in the water at a 28-degree angle of depression. What is the horizontal distance from the airplane to the raft? Okay, so let's draw a triangle. Okay, so the plane is has an altitude of 8,900 feet, so the height is 8,900 right here. This is the angle of depression. which is 28 degrees. And it asks us what is the horizontal distance from the airplane to the raft. So this value, same value. So we're going to use the same measure, or the same trig ratio. So we're going to use tangent of 28 degrees is equal to opposite over adjacent. So opposite is 8,900 and adjacent is x. So when we write it in terms of x, we're going to write x is equal to 8,900 over tangent of 28 degrees. So x equals, and we're going to type this in. So clear everything out, 8,900 divided by tangent of 28. And we get 16,738.46, so we'll round up to 0.5. So x is equal to 16,738.5 feet. All right, and then the last question, Max is sitting in the stands at the baseball stadium. He catches a foul ball and decides to throw it back to a player standing at first base. If the horizontal distance from Max to the player is 61 feet and the ball travels 76 feet, what is the angle of depression from Max to the player? All right, so same triangle that we've been working with. All right, so we're going to be looking for the angle of depression, right? So this is the angle of depression. This is theta. And we're going to look for what the measure of theta is. Let me redo this real quick. All right, this is good enough. All right, so this is theta. And actually, let me, because I need more space. All right, so this is theta. So it tells us, so this is where Max is sitting, and this is where the baseball player is at. So this says that, so Max, the distance from the horizontal distance from Max to the player is 61 feet. So this is 61 feet, and the ball travels 76 feet. So that means that this right here is 76 feet, right? Because this is Max, this is the baseball player. And it asks us, what is the angle of depression from Max to the player? So we're looking for this right here, right? So in reference to this angle, we're given the hypotenuse and the adjacent side, right? So we're going to be using cosine. So cosine theta is equal to adjacent over hypotenuse. So adjacent is 61 and hypotenuse is 76. So now we're going to write it in terms of theta, and we're going to be using the inverse of cosine. So theta is equal to the inverse of cosine of this, right, of 61 over 76. So you're going to type this into your calculator. So you're going to go into your calculator, type in second, and cosine gives you the inverse of cosine of 61 divided by 76. And you get 36.61. So we'll round down to 36.6. So theta is equal to 36.6 degrees. All right, so that's it for this lesson on applying our trig ratios and the inverses of our trig ratios. If you have any questions, again, please let me know so that I can help you out.